Hello everyone, welcome to High Tech Study Plus. We are back with another video on the chapter electricity. If you haven't watched the previous videos, then do give it a look. So let us begin. In today's class, we are going to discuss about Ohm's law. Ohm's law states that the potential difference V across the two ends of a conductor is directly proportional to the current flowing through it, provided that the temperature remains constant or the temperature doesn't change. So as per this law, if I increases, then V also increases in a conductor. So we can write this as V by I is equal to a constant. Let that constant be R. R is called the resistance of the conductor. So this equation can be written as V is equal to IR. This is a very important equation and it will help in solving a lot of numericals. If we draw the graph for an ohmic resistor, then we will get a line as shown in the figure. We will get a straight line. So let us now define the resistance of the conductor. So resistance of the conductor is its property to resist the flow of charges through it. So whenever charges will flow through a conductor, it will try to obstruct them or to stop them. So this property of a conductor is known as the resistance of the conductor. So we can write R as V by I. So R can be represented in this way. Now the SI unit of resistance is ohm, written as this. Now let us discuss the factors on which resistance depends. Resistance depends upon the length of the conductor. R is directly proportional to L. Suppose we take two conductors and the length of one conductor is this much, say 1 centimeter, and the length of another conductor is 2 centimeter. Then the resistance offered by the material will be more if its length is taken to be 2 centimeter than 1 centimeter, because length of the conductor determines the resistance. How? If the length increases, then the resistance of the conductor also increases. Now R also depends upon the area of cross section of the conductor. R is inversely proportional to area of cross section. So if area of cross section increases, then the resistance decreases. Let us consider that these two wires as shown are made up of the same material and the length is also same, but their area of cross section is different. So as per our knowledge, if the area of cross section increases, then the resistance decreases. So resistance will be less in the first case and the resistance will be more in the second case. So in this way, resistance of a conductor varies. Now we can combine these two and we can write R is proportional to L by A, where L refers to the length of the conductor and A refers to the area of cross section. So we can represent this equation in this way also. R is equal to rho L by A, where rho is a constant and it is known as the resistivity of the material or resistivity or specific resistance of the material. So resistivity or specific resistance of the material can be defined, and for this we just need to write this equation as rho is equal to RA by L. If we take the magnitude of area of cross section and length to be unity, that is 1, then we can write rho is equal to R. So simply we can define rho as the resistance of a material of unit length and unit area of cross section. Now let us try to solve a question given in the book. The question reads, let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half its former value. What change will occur in the current through it? So the solution will be, consider initially the potential difference to be V and the current to be I and the resistance to be R. So now new potential difference will be V by 2 as we have been given decreases to half. So since the initial potential difference was V, now it has decreased to half, or it has become V by 2, that I have mentioned here. Now the resistance remains constant, so resistance will be capital R. We have been asked to find the current. So how are we going to do this? We shall be using Ohm's law here. V is equal to IR. So in the first case, V will be equal to IR. In the second case, V by 2 will be equals to I dash R, where I dash is the current in this case. So let us consider current to be I dash here. If we divide these two equations, then we will get V by 2 is equal to IR divided by I dash R. So it implies that V will get cancelled, R will get cancelled. 2 is equal to I by I dash, or we can write it as I dash is equal to I by 2. If the potential difference is decreased to half its former value, then the current will also decrease to half its former value. So this is our answer. That's all for today. Thank you.